Viridiscope is a sampling device designed to meet the criteria driven by NDA of safer, cleaner, faster and more cost-effective. The current tool is designed at this stage to specifically sample concrete surfaces, but the next stage will look at application to a wide range of materials such as plaster and brick surfaces. We may also include wood and various metals, but currently concrete is our focus. The existing approach to sampling is to manually drill with all its inherent problems, particularly the generation of hazardous dust and the necessity for the operator to be in close proximity to the radiologically contaminated area. Viridiscope is quite different to any existing tools. This new approach uses an infrared laser to remove small amounts of material from the surface and transport it away from the sampling point to collect it in a suitable form for a range of analyses. One of the most important factors we have had to address is to be able to collect a representative sample from the wall or concrete surface. That is to say, to ensure that the chemical composition of the sample taken is not altered. The laser ablation process requires high temperatures at the sample surface. The sample is taken by firing a focused beam of laser light, which is very energetic and high energy, directly at the sample surface, so that a small amount of concrete is removed in the form of very small particles. It is most important that the sample maintains its integrity through the sampling and collection process, and this is where some significant development and experimental work was necessary. We are currently working at 20 metres distance between where the sample is taken and where the sampled material is finally collected. To do this, of course, we also need to have a 20-metre sampling line and control cable. This is important because the laser source and control electronics can then be kept at a safe distance from the active surface.
The device can be operated in two ways: handheld by a trained operator or remotely deployed on a platform like Wall Rover or the OC Robotics Snake. Because of the nature of the device, using a laser to remove the sample, it is necessary to have a number of safety features in place to protect the operator. So we have safety systems incorporated into the sampling head itself and the necessary electronics to allow us to monitor the status of the system. People will be familiar with news stories of inappropriate use of lasers, and our major focus has been to ensure that operation is safe at all times. The sampling head contains specially designed optics to focus the laser light on the surface. There are 3 proximity sensors built into the sampling head to continually monitor whether it is in contact with the surface. A feedback control system between the sampling head and the control box ensures if at any time the sampling head loses contact with the surface, the power to the laser is cut. You can see the 20-metre data line, sampling line and the armoured optical fibre tethered together and covered by a disposable plastic sleeve. The sample is drawn through the sampling tube by vacuum. The laser control box houses the control system for the laser itself. The top box houses the laser light source and safety interlocks. The sample line connects directly from the sampling head to the filter pod where the sample is collected. Viridiscope requires 2 people to operate it. If operated manually, one person can perform the sampling whilst the other is needed to change the sampling pods over between collections. If the sampling head is mounted on an ROV, then one person is needed to drive the ROV whilst the other looks after the sampling pods. Operators must be trained to set up and safely operate the system. The sampling pods and heads are designed to be disposable. The pod is specifically designed to take a 5 cm diameter filter, the standard size of a counting tray used by the main manufacturers of gas proportional counters, allowing direct analysis for gross, alpha and beta. It is obviously also suitable for gamma counting and any other direct technique of analysis. If required, the filter can be removed from the mesh support and digested for solution methods of analysis for radioactivity or elemental analysis. The sampling head can be used for a complete session, such as a day's work. It depends on the surface, could be longer. It is designed for multiple use. The sampling head comes apart so replacement parts can be fitted, and it's light and manoeuvrable. It can be adapted to be used on a range of ROVs, and the OC robotic snake is a good example. Wool rover is very manoeuvrable and can remain static during sampling or can move over a large area while sampling is taking place. So you can see it is potentially possible to collect a significant number of samples in a relatively short time in a form that can be sent to a laboratory, whether on or off-site, for analysis. The approach is clean, safe and easy to use, giving it significant advantages over conventional drilling. The sampling head and sample collection pods can be treated as consumables, which are easily disposed of. If the sampling line were to become radioactively contaminated, it can be easily replaced. If the sampling head and tethered control line, sampling line and optic fibre become contaminated, they too can be disconnected from the control system and disposed of. Mark Dowson is the Business and Technology Manager of Sellafield Limited's Technical and Engineering Directorate.
At Sellafield there are approximately 2 million cubic metres of concrete to be analysed and eventually decommissioned. By adopting this novel technique, the operational costs and exposure to radiation doses for workers could be minimised. If the lasered material is analysed in situ, there will also be significant savings associated with not having to send thousands of samples to the labs for analysis. This is particularly relevant during characterisation for active facilities during post-operational clean-out, where Viridiscope will also provide near real-time information for operators on the ground. Increasing the efficiency of analysis means larger volumes of concrete can be more accurately characterised and potentially classed as low-level waste rather than intermediate-level waste, presenting a significant cost saving to the UK taxpayer. The whole life cost savings could be many tens, perhaps even hundreds of millions of pounds.
Viridiscope will ensure that the characterisation of nuclear sites will be safer, cleaner, faster and more cost-effective.